6-4. F of x is this. Wonder what that looks like. It's not something that I'm real familiar with. So if we put 0 in here, we get 0. If we put 1 in here, we get 1 over the square root of 2, which is a little bit, but not 1. 1 over the square root of 2 is square root of 2 over 2.7071. I think that's what that is. So if this is 1 and this is 1, it's not quite there. If I put 2 in, I get 2 over square root of 9, which is 3. 2 over 9, which is 2 to the square root of 9 is 3 2/3. 2/3 is 0.6, so that's coming back down a little bit. And if I put 3, let's just go to 4. 4 over 4 squared is 16. 4 cubed is 64 plus 1 is 65. Square root of 65 is close to 8. So we got 4/8, which is about a half. So I think this is going to do something like that. And we're going to spin it about y-axis, so it's going to do something out here. So to do disk method, this would get tricky because we'd have an inside and outside radiuses, and we'd have to solve this for x, and don't want to do that. So this one's definitely a shell method one, and that's what this section's about, shell method. So in shell method, we slice parallel to the axis, which is y-axis, so we're going to slice this way. Its reflection will be over here. And we'll get this shell, this ring, this way. The thickness of the wall of this is going to be in the x direction, dx. So we're going to have the integral. It's going to be a dx, and x is going to go from 1. We're not even doing this part in here. We're just doing from here to 4. From 1 to 4. And we don't have to worry about holes when we're doing shell method. They're already calculated in. It's 2 pi radius. The radius of the shell is in the x direction, which is what we're, thickness is in the x. So we can just put x times the height. Well, the height is y. Well, we don't want to put y in here. We're going to use what y is equal to. X over the square root of 1 plus x cubed. So we got x squared over this with a 2 on it, if we want to put the 2 in there. But I'm just going to let the inside of this be u. du would be 3x squared dx. dx is du over 3x squared. So this will become 2 pi integral. I'm changing to u. If I put 1 in here, 1 plus 1 cubed, that's 2. 4 cubed is 64 plus 1, 65. That would be my new limits if I figured them out. This would be x squared over the square root of u, and dx becomes du over 3x squared. The x squareds cancel. I'm in terms of u. This is u to the negative 1/2 when I move it up. So to integrate it, I'm going to add a half, and so it's going to be 2 pi integral up. Integrated will be u to the 1/2 divided by 1/2 from 2 to 65, which is going to be 2 pi square root of 65 over 1/2, which is times 2. I'll just put that out here. Both of them are going to be times 2, so I can pull it out. And I'm going to put 2 in there, and I'm going to get minus the square root of 2. 4 pi times the square root of 65 minus the square root of 2. Shell method on this one. Okay, what the heck is this going to look like? When we put 0 in for x, we get 1 over the square root of 1, which is 1. When we put 1 in for x, we get 1 over the square root of 2, which is 0.7. If we put 2 in for x, we get 1 over the square root of 5, which is a little bit smaller. So it's something that's dropping down. We're spinning this about x equal 0. X equals 0 is that line. So its reflection over that would be over here. The slice shell method would be parallel to x equals 0, something like this, which is going to be a y high. It's going to slice will be over here. The ring that we get will be this way. The thickness of the slice will be sideways, dx. So we're going to be integrating 2 pi radius. Radius is x. Height is y, which is, since we're doing the thickness is dx, we want it in x, so y in terms of x is 1 over square root of x squared plus 1. And we're going to integrate from x is going to go from 0 to 2. 0 to 2. Well, this is, again, another just simple substitution. U equals x squared plus 1. du equals 2x dx. We get du over 2x is what we're going to replace dx with. And so we're going to get 2 pi integral from, let's see, we're changing variables. 0 in here is 1. 2 in here is 4 plus 1, 5. And we're going to have x, 1 over the square root of u, du over 2x. X's are going to cancel. The 2 is going to cancel. The integral of the square root of u, 1 over the square root of u, that's u to the negative 1/2. When we integrate it, we get u to the plus 1/2, so we get pi, the 2 is canceled, u to the 1/2 over 1/2, so that's 2 square root of u, evaluated from 1 to 5, which is 2 pi. We can pull the 2 out of this and do square root of 5 minus square root of 1. Well, we got this AB region stuff. Oh, I forget which region. 44. And I didn't bring the book. I'm not near the text. I believe we were doing region B in this one. And we're doing it about x equal minus 3. So that's way over here. This region, I'm going to do B. If it was A, it'll be a little bit different, but I'll do B. This about minus 3, x equal minus 3. Well, the height if we did shell method parallel to this, the heights would be determined by the equation. If we did disk method, the disk would be the same for part of it, and then they would change for the other part. So on 44, I believe I have the choice, and I would choose to do shell. If it was A, I would still do shell. It would be those around that. I'll actually set up both of them here just in case I'm doing the wrong one here. So for B, which I think it is, the slice in the shell, it would be matched way over there, would be 2 pi r, which is x plus 3 times the height, which is y, which is x squared plus 2. And x would be in the slice thickness is dx, 2 pi r height. And x would go from 0 to 2. That's for region B being taken around that. If I was doing region A around that, the slice would still be this way. So the radius would still be 3 plus x. This is what changed. So if it was doing region A, it would be 2 pi 0 to 2 x plus 3, same radius. The height would now be 6 minus this. So I'd have just 6 minus x squared plus 2. And if you just multiply this stuff out, it's a pretty easy thing to integrate. If you simplify that and then FOIL it out, that's a pretty easy thing to integrate too. So that's the idea for 44.